And I have
Progress.
did you try this? I have posted new paper. Okay, I'll share the screen. This paper we discussed last week. So this we finished this, right? Yeah, all the questions we discussed. Alkene past structured essays, alkene reactions past structured essays we discussed. Then this paper also we discussed some selected questions under benzene and alkene. Benzene and alkene we discussed. Right? There are a few more questions left here. And this paper I posted. So have you all done this? This is from again isomerism past structured essays. Draw the structure of 2-methyl propene. Drawing the boxes P and Q respectively. So I have not given the space here. Actually, structured say you get space, but here when you are going to take a printout, unnecessary take like additional paper cost or like waste of this one. So that's why I put only the question. I didn't leave the space here. Otherwise, the structured essays you are getting um, the blank space for each question. Propose a mechanism for HBr 2-methyl propene. How many of you have done this? Please raise the hand. This paper. Then I can discuss, or else I'll discuss this next week. How many of you have done this? None of you. Okay, then shall I discuss this next week? You can do this, right? Because alkenes we have done. Aliphatic hydrocarbons, alkene, alkane, alkynes we have done. So this is from isomerism. Isomerism topic we have done completely. So then you should practice all the past questions and the MCQs from isomerism. Some MCQs only I discuss isomerism, but not the essays and structured essays. Okay, then we'll discuss this next week, right? Yeah, because most of you are not done. Then 2020 paper have you all done? MCQs, all the possible MCQs. 2020 paper, we didn't discuss any of this, right? Did I discuss? Ramadi? Sorry, remember I didn't do 19 paper I discussed. How many of you have done 2020 paper, all the possible MCQs? Yes? 2020, like previous LL paper? Okay, right. Then we'll discuss that. Okay, all of you are done. Now next, so next year try to do this, right? Isomerism one. Because before you forget isomerism, so we are done or cis trans, optical, enantiomerism, stereoisomerism and all. Right. Okay, we'll discuss this. 2020 paper MCQs, right? Okay. First MCQ. Pramodi, did I discuss any of this? No, right? 2020 paper, I didn't discuss any of the MCQs, right? Yes? No, okay. Then we'll discuss this. 19 we finished everything. No, 19 2019 MCQs. Yes, we discuss all the possible questions, right? Okay. Then 2020 paper. So those who have done, you can put the answer to the chat. Question number 1. Consider the following discoveries made in regard to the atomic structure. Mostly the first MCQ they give like historical background of chemistry. Yes, what is the answer? You can quickly post the answer to the chat, or you can unmute and tell me the answer. Two scientists who discovered 1 and 2 respectively. So the question is, who discovered these two? So this is like directly the knowledge based questions. Knowledge based questions. Positive rays. Sometimes we used to say anode rays, positive rays, and the other one is radioactivity. Radioactivity. Okay. Right. So most of you gave the answer. Okay, first one, Vinhara, Ishara, Tamasha gave, yeah. Pramodi gave first answer, all the others gave fifth answer. J.J. Thomson and Henry Becquerel. J.J. Thomson and Henry Becquerel. Pramodi gave fifth answer. Goldstein and Henry Becquerel. Anyway, radioactivity discovered by Henry Becquerel, no doubt about that. Radioactivity was discovered by Henry Becquerel. Now, who discovered positive rays? So, anode rays. Actually, it was done by Goldstein, not by J.J. Thomson. Not by J.J. Thomson. Remember, J.J. Thomson discovered the electron, but actually the name was given by Stoney, and actually cathode rays was discovered by Sir William Crook. Cathode rays led to the discovery of electron. Cathode rays led to the discovery of electron, but cathode rays were discovered not by J.J. Thomson even. If you want to write those things, additional information, cathode rays was discovered by who discovered? Who discovered cathode rays? Yes, not by J.J. Thomson. Same as these positive rays. Positive rays sometimes it's referred to as anode rays. Cathode rays are negative. Negative. So then it's from the cathode and towards anode. Cathode rays contain negatively charged particle. So the anode rays contain positively charged, that is proton. Protons, H plus. Discovered by Sir William Crook. Okay, very good. Cathode rays by Sir William Crook. Very good. Okay. So those things also they can ask in the future. You will not get the same question as it is. So therefore, under each MCQ, copy down the others. If you know these, no problem, no need to worry. If you know all this, no need to worry. Otherwise, you have to copy down. Right? Cathode rays by Sir William Crook. Anode rays or positive rays by Goldstein. And then radioactivity Henry Becquerel. Then in addition to that, right, electron, the name was given by Stoney. And the term atom was introduced by a Greek philosopher called Democritus. Democritus. Okay. Then next question. And the other one is that Geiger Marsden, what is this called? Gold foil experiment, those things also you should know, right? So I don't have time to tell everything. Please refer, because at least essay type and structured essays, they don't ask these names, mostly first or the second MCQ, mostly in the paper, right? Question number 2. Question number 2, number of electrons in the manganese 25 and that the quantum numbers respectively. Okay, what is the quantum number? Manganese atomic number 25 they have given. Anyway, the periodic table is given. Number of electrons. L0 and Ml minus 1. D block ne? Yes, who can give me the answer? Question number 2. Some of you gave the fourth answer, some of you gave the second answer. What is the correct answer? It's only 3 of you. What about Pramodi and Vishna, Tamasha, and Ishara gave? Pramodi, what is the answer for the second MCQ? So L equal 0 means S orbital. L equal 1 P orbital. So that means minus 1 is P. Ne? So L means L equals means this S, that you should know. Right? Okay. If you write the, you should write the configuration also. So L minus 1 you get for the P. This one you get for the P. If you only can put an arrow and write, this is for P. Shall I write this? I don't know whether you can remember them now. Okay, I'll use the white screen and give this. You might have forgotten now. So you should write the configuration of manganese and then you can assign these letters. Okay, let me explain this way because some of you have not got the correct answer. Say some of you have got the second answer, some of you have got the fourth answer. Yeah, second and fourth. Okay. So actually the answer is none of this. That's the problem. Anyway, let's see. 1000. Give me a second. I'll use this white background to write the answers. Then it's clear, right, this one for the explanation. Okay, question number 2. Question number 2. Okay, now you can see the screen. Now, first one. I'll write here. If you have forgotten any of this, please quickly copy down. L. So L can have the values L0, 1, 2, 3. So L0 means S orbital. S. L1 means P. L1 means P. L2 means D. L3 means F. That you should know. L can have the values starting from 0 integer values. Then if you take ML, now look at ML. If you take ML, right, now let's see ML. See the values for L. Then ML. ML, so here it's 0. ML what? Minus 1, 0 plus 1. Then when is L equal to 2? So this minus 2, minus 1, 0, plus 1, plus 2. That means from minus 1, minus L to plus L, ML can have the values from minus L to plus L. So you can, if you want to write within bracket, minus L to plus L. Right. Now let's try the configuration of manganese and then you can get the answer easily. Now let's try the configuration of manganese. Now you can write the answer easily. Now probably has changed the answer after writing. Okay. Now let's try the manganese configuration. So this is general chemistry easy question. Manganese atomic number 25, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5, 3d5, 25, 3d5. Now let's assign the values. So they are asking L equals 0. Okay, I will now put the values. Look at this. if you take 1s ml0 ne? ml0, right? Here ml0, that we don't need to consider. Here 0 and here 0. Then if you take -1, you take these values. I put ml, when is ml0, these ones, ml -1. Let's mark that also. I'll use a different color. This one can have -1. Then this one can have -1. And D can have -1. Do you understand now? So for -1, -1, 0 plus 1, -1, 0 plus 1, -1, 0 and +1. Here also -1, 0 and +1. Here, here -2 also you get, -2, -1, 0, +1, +2. Now remember, all of you have got the wrong answer here. Now you are putting the correct answer. Good, you have understood that. From Udaya and Ishara, you have changed the answer. Good. Now let's count the number of electrons here. So here you get -1 electrons. So now I'll mark the -1 electrons. -1 electrons. -1 electrons now. -1 electrons here too. Right? Here you get how many electrons? How many electrons? 2. Here how many electrons? 1. So altogether you get how many electrons? 5 electrons. 5 electrons. L equals 0, how many electrons are you getting? 2, 2, 2. Right? Here you get 2 electrons. Here you get 2 electrons. Here you get 2 electrons. And here you get 2 electrons. So total will be 8 here. Total will be 8. Here total will be 5. Did you get it now? Did you all understand? Good. Tamasha now put the third answer. Earlier I think most of you have put what? Tamasha put the fourth answer. Now you put the third answer. Good. Ishara, earlier you put the second answer. Now you have put third answer. Good. Pramodi, earlier fourth answer. Now you put the third answer. Okay. Who didn't put this? Now Ishara, Tamasha and Pramodi. Vinhara, did you understand Vinhara? Vinhara also gave the second answer. Did you understand Vinhara? Okay, right. So be careful, this type of questions, tricky questions. So apparently, like, you should better now write like this. So if you can't remember this, if you have more practice, yes, you can directly get the answer. But otherwise, if you have less practice of doing these things, then you have to work out like this. Anyway, no harm writing this. You can quickly write. Okay, because I am writing on the screen with the writing pad, so then it takes time, and with the explanations, but you can quickly do it. Okay, but anyway, you should better copy down this, because all of you got the answer at the beginning. None of you got the correct answer first attempt. All of you, the first attempt wrong. You gave 2 and some of you gave 4. 2 and 4, right? Anyway, so remember, quantum numbers introduced to new syllabus. Introduced new syllabus in 2000, I mean, up 2011 onwards, they introduced quantum numbers. So before 2011 papers, no quantum numbers. Shall I erase this now? Anyone still copying down? Anyone still copy down? Give me a second. Right. Now next question. So I'll erase the screen. Question number 3. M, an element belong to the second period of the periodic table. It forms a covalent molecule MCl3 which has dipole moment. The group of the period M belongs. Okay, what is the group? Okay, remember I have posted you IUPAC periodic table also. A periodic table is given at the end of the paper, right? Periodic table is given at the end of both MCQ and essay type paper. Therefore, but they will not give everything. They will give the symbol and the atomic number, right? Symbol and the atomic. Now here, this is how you get the. This is how they will give the with the LL paper the periodic table. Can you see here? Only the symbol and the atomic number. But for your information, I think recently I have posted IUPAC periodic table also to your WhatsApp. I think it's IUPAC periodic table. I remember I gave. Didn't I? I sent right the periodic table IUPAC. Yes. This one. This periodic table. IUPAC periodic table. So you can get the name of the element and the relative atomic mass RAM. Average relative atomic mass. You can use this also because all the periodic table not correct. Some of the periodic table there are some times so this RAM and all there can be some times small all what you download in the internet also not 100% correct, right? Anyway, periodic table you don't have to worry. Atomic number also they will give the mass number for the if you get a calculation in the MCQs or the SAO structure they'll give the mass number separately, the RAM separately they'll give it. Then no need to worry about that. For that particular question they'll give, otherwise in the periodic table they don't give it. So yeah, only the atomic number and the symbol, right? Now let's see paper, back to the paper now. Question number 3. So sometimes they give the long form of the periodic table. So you should be familiar with the periodic table also. If you're familiar with the periodic table, some inorganic chemistry questions is easy to get the answers, right? Okay, now did everyone post the answer for the question number 3? What is the answer for the third MCQ? Right. Most of you get the second answer. Ishara second, Vinhara second, Pramodi second. What about Tamasha and Tamasha gave fourth. Tamasha gave fourth. All this gave second. Fourth and second. Let's see. Fourth one, Tamasha. Fourth one. 15 like nitrogen, phosphorus, arsenic, group 5. 13 means actually both group 5 and group 3 elements form the PCl3, NCl3, PCl3 as well as AlCl3, BCl3. So these are the two groups which form MCl3. And the other one they have given second period. Second period means what? That is nitrogen, phosphorus and boron, nitrogen, phosphorus, nitrogen and boron, NCl3 and BCl3, and is covalent molecule, and it has a dipole moment. Now this is very, very important. Covalent word important and has a dipole moment important. Then you can filter the answer out of group 5 and 3. So if you take the electronegativity difference, nitrogen and chlorine, so NCl, there are 3 identical bonds. NCl3 pyramidal shape. So therefore it has a dipole. But if you take BCl3, even though there's an electronegativity difference, bonds are polar, but the molecule is non-polar. Molecule is non-polar. Therefore the answer is fourth. It's very easy. Answer is fourth. Who gave the, I think most of you gave the second answer. Only Tamasha gave the fourth answer. Ishara, Vinhara, Pramudi. So these are very simple questions. Don't do mistakes for these kind of one. Right. Okay, I'll explain now. What are the two groups now? MCl3 formed by group 3 and group 5. Okay, I'll quickly tell. Okay, look at the screen everyone. Because except Tamash, all of you are wrong. MCl3 formed by two groups. Group 3 elements and group 5 elements. Group 5. So and they have mentioned second period. Second period. So then one possible answer is BCl3. Second period elements BCl3. And not group 5 NCl3. Now the BCl3 trigonal plane. BCl3 trigonal plane. And NCl3 is pyramidal. Pyramidal. So out of these three, each bond is polar. In both the bonds are polar. If you want to write this, each molecule in each bond, in both bonds are polar. In both molecules, bonds are polar. Bonds are polar due to the electronegativity difference. But this one is, molecule is non-polar. This is non-polar molecule. Molecule is non-polar, bonds are polar. Non-polar molecule. This is polar molecule. Plus, therefore this non-polar molecule, dipole moment is 0. 0 dipole moment. 0 dipole. This one, it has a dipole moment. Therefore, what matters for the, when you be careful in the exam, bonds dipole and the molecule dipole. So any bond, any heteroatomic bond, the due to the if electronegativity difference is 0 only, the dipole moment 0, right? It's given by this mu. Dipole moment is 0 for what? Any homoatomic molecule. Homoatomic molecule. So but this is will not be equal to 0, or if it is greater than 0, mu or the dipole moment is greater than 0 for heteroatomic bonds. Heterobonds. I will just in short form heterobonds. Heterobonds means bond is formed between different atoms. These homobonds. Homobond. Now that's how you check the in bonds. So this is in case of bonds. This is how you check what matters for the electronegativity matters for the bonds. But when you take molecules, is a different scenario. Molecule, the geometry of molecules matters. Electronegativity difference matters. Then the geometry as well as, and whether bonds are identical or not. If you can write in short form, when you consider a molecule, the dipole moment depends on what? Dipole moment depends on these factors. In a molecule, dipole moment depends on number one, shape of the molecule or the geometry. Number two, type of bonds, nature of bonds, or identical or non-identical bonds or non-identical bonds. That's what matters. Whether bonds are identicals or not. Whether bonds are identicals or not, and the shape of the molecules. Understood? So then what is the answer here? Answer is second. Answer is second. Answer is second. NCl3 is not ionic. NCl3 is not ionic. NCl3 is covalent. BCl3 also covalent. BCl3 also covalent. NCl3 both are covalent. What is the electronegativity? Okay, Pramudi asked that question. Isn't NCl3 ionic? Pramudi, what is the approximately electronegativity of nitrogen? Is 3. It's 3. Nitrogen is 3. And chlorine also, the book value is 3. Chlorine also book value is 3, approximately 3. But actually it's not 100% is 3, so it's 2 point something. Therefore it's around 2.8 or 2.9 as I remember. So then there's no big electronic difference. Nitrogen and chlorine, there's no big electronic difference. Therefore NCl3 is not ionic. And NCl3 is, you can search in it, is not a solid. Then otherwise it should be a solid. So if you want, you can mark the dipole moment here. This is how you mark the dipole moment. The second one, the dipole moment is upwards like this. Like this. But the other one, we can't mark the dipole. Did you get now why the group 3 means 13 group? Group 3 means 13 group. Long form of the periodic table, 13 group. And this 15 group, long form, IUPAC one. So the answer is second. Is that clear? Any questions, any doubts about this? Answer is second. Who got the correct answer? This is the symbol for dipole moment. This mu is dipole moment. Okay, I will show you now Professor Dharanegala article about this mu. I think this is one problem. The some of the Moses students, they are lacking this knowledge of this dipole thing. Give me a second, I will open that. Professor Dharanegala. Right. I will recently one of the top school, even the school teachers has messed up this, and some students were asking sir which one is correct and whether that one or this one, and there was a problem. Give me a second. Now that question, you have any doubts now? Is that clear? This one. Can you see the screen? Right. You can see the screen, right? Okay. Let me explain. So he is the chief of the A-level chemistry paper. So I think most of them they know that about that. He is about resonance he has written because he is in charge of inorganic chemistry. Professor Dharanegala, electronegativity. So this is the electronegativity values. I don't know whether this clear. Can you see? Nitrogen 3.0. Chlorine also they have given 0, but anyway, no need to memorize these values, right? Then they are not available from the bookstores to buy because it is from the article. Usually the people, they don't publish the books. That's an equation for the dipole. Molecular shapes. Right. Is a dipole moment. Yeah. Look at the bottom here. What is this? Is dipole moment. There's an equation here. This is mu here and q. This is the radius. So can you see here the bottom, rightmost side bottom? Can you see the rightmost side bottom? Magnitude of dipole moment is called, so it's a vector, right? It's a vector. It's a vector. If you take HCl, so it's a vector and it has a magnitude. That's why we put if two equal opposite charges q and q plus and q minus separated by a distance r, then magnitude is given by this mu here mu. Now you get a coronavirus also mu, alpha, beta, what alpha variant, delta variant, alpha. So I think they will go for all the alphabet of the Greek alphabet now with this COVID-19 variants, like it's multiplying and the new variants coming, right? Mu also they have a South African variety mu or something like recently they told like, so okay, that's a Greek letter. So this mu they use in physics also. So that is a symbol of the dipole moment. So that's a product of what? When the distance, when the bond length increases, what happens? Dipole moment increase. When the bond length increase, dipole moment increase. And when the charge increase, so what are the two factors affecting the dipole moment? Charge and the radius, right? Or the bond length. Actually, this is radius. Actually, not the radius. Actually, here the bond distance, the distance, and it's measured in coulomb meters. Distance given in meters, charge given in coulombs. So coulombs into meters, coulomb meters. That is the unit of dipole moment. So this is also, I will discuss questions. I'll explain this again. Otherwise, otherwise I have to teach you theory completely today. So whenever like relevant questions comes, I'll explain this again. This is bit important. Okay. I don't think there's any books published by Professor Zaraniagal available from outside, but anyway, he is the chief of the A-level exam paper. Right? A-level paper. Now let's move back to the previous one. Now the Pramodi asked what is mu, that's why I gave this, right? Okay. That is a symbol used for the dipole. Right. So I don't think they haven't asked to calculate, therefore no equation is not much important. Equation is not, I don't think they'll ask you to calculate this in the exam. So in the resource book also they have given, I think, about this organic chemistry. General chemistry they might have given this. General chemistry. Now when you come across a problem, you should know how to solve that, or the source of information. That is very, very important. Source of information, very important. Otherwise you are in trouble. You don't know how to clarify your doubts. Some problems having that also. Sure. This is resonance hybrid and resonance structures. Here, can you see Pramodi? Right here, page number 73, resource book. General and inorganic chemistry page. Can you all see the screen? Page number 73. They have given about explanation about the dipole, and they have given the equation also here. Charge of the poles into bond length. But anyway, they haven't given, I don't think they'll ask the calculation, but anyway, you better remember this. Charge in coulombs and distance in meters. Right. That's all they have given. This only this not. Right, okay, back to the paper again. Any doubts? Any more doubts? So did you all understand now how come the answer is second for this question number 3? Huh? Right. Then question number 4. Now, when you do something, you should know for reference, you should know some sources. Otherwise, you are just limited insert all this and that the teacher gave this. No, don't limit from there. You should explore this because we can't keep on now. You have up to different extent. You need the explanation. So therefore, individually, if you're going to this, it's not practical. So therefore, I gave a start, and for the clarification, I will give the answer how to get the answer for this question. But if you have the wrong answer, either you have done a careless mistake or you don't know the theory behind this. If you don't know the theory behind this at all, then you have to be careful. Then this explanation is not enough. You have to refer the sources. Sources of information, or you have to do a literature survey. Right? In other words, you have to search more and more in the internet. Don't limit only the school teachers or one not internet, but or everything that you download from the internet also not 100% correct, but reliable sources. Right? American or Australian Chemical Society or American Chemical Society or scientific journals or that, or else at least because Sri Lankan very less few books no, so no mostly the people they publish this unit wise stuff, but you should explore a bit more. Actually, my advice, the best thing, okay, I'll give a small example. Okay, this is what you should know. Most of the teachers they don't tell it actually. You look at this now. Who has written this? Your organic chemistry, Professor A.M. Abesekar, right in panel. Professor Gunahera and Professor Bulugahapiti, Ruhuna Open University and University of Sri Javardhanapura. Right. So that is the right in panel. And how they have written this organic chemistry. Look at the end of this resource book. They have given some references. Can you all see here? Right, Morrison, organic chemistry, 2010, and Solomons. So if you refer these two books, so then that you can get more information. The university students also first year they refer these two, Morrison and Solomons, organic chemistry, 2009 and 2010. Right? So this I think mostly UK and USA books will answer. So there are some websites. So actually it's not legal, but there are some website you can download any ebook library and ebooks you can download. You can keep a sample. I can't share this. It's not like violating their copyrights, but anyway, electronic medium we can disturb. But in Sri Lanka, the people do this. University lecturers they have the soft copy. If you take general chemistry, okay, general chemistry written by Dr. Kaumal, Columbia University. Okay, here look at this. Either you should refer their books or then no need to ask from anyone else. No? That's it. That is then even your teachers and everyone they refer these books, and they even for making the paper they refer this. So this writing panel, unit 3, Dr. Kaumal. Can you all see the screen? You should refer these things also, not only the content. And there can be mistakes in the resource book. Then you should go for the original source. You understand what I'm saying? Dr. Russell from Kalani, Dr. Prashant from the University of Sri Javardhanapura, Dr. Kaumal from University of Colombo. So unit 1 by Dr. Russell, unit 2 by Dr. Prashant, and unit 3 by Dr. Kaumal. If there's a problem in unit 2, we call them. If now when I read the resource book, if there's a problem, the unit 3, the resource book, then I call Dr. Kaumal because he's just 1 year senior to me in the university. Now, a senior batch. So I asked, so what has happened? So there is a printing mistake or something has happened because they are writing the teachers also involved for this. And so the only book you have for the reference now resource book also I'm telling there are a few mistakes in the English medium one. Then you have to refer the Sinhala medium one. Okay. Now at the end of this, can you all see the resource book? They have given. I think they should have given the reference here also. Haven't they given the references? So they should give the references. J.D. Lee and some. Wait, I think they might have given at the beginning. So please refer the references given in that book. They must have given somewhere, right? Mostly they use. There's a book. If you want, I'll send to your WhatsApp for the reference, not the entire video, but I'll give the name of the book. They have not given that here, I think, right? they had put the reference. So see whether I think 1, 2, 3. So the for general chemistry they might have not given the references. If they have given, then you can refer directly that book, right? But most of the results for the this one they have given it now. Example, environmental pollution they have given the resource book. So you can refer the now some student asking, sir, what should we buy? What are the books that you should refer? So then you can directly refer this. So example, now this one can you all see? This is physical chemistry. See the references they have used. These are the books they have used for when writing the physical chemistry longest lesson in your syllabus. And drinking water, Sri Lankan Standard Institute drinking water standards. In Sri Lankan one they have used. All this English book. 1985 books also they have used. Inorganic chemistry. Introduction to inorganic chemistry. Cornell, this is a good one. Cornell one. Then in addition, if you take the industrial chemistry also, I think they have given the references at the end here. Most probably they might have given. Industrial also they should give. Now this one inorganic chemistry. Whenever references are available, please refer that. If possible, at least you should refer the resource book. First you should refer the resource book. But for further clarification, sometimes even they should. But some of the questions in those books you can get in the A-level paper. That's why I'm telling this. Some of the questions in these books, so you can get questions and answers there in these books. Chapter 10 exam practice questions are there. So then sometimes similar ones you can get even in the oral paper, your A-level paper. Right. Okay. We're discussing this, right? Now number 4, the number of unstable Lewis dot dash structures that can dot dash means Lewis structures, right? That can be drawn for the peroxynitrile acid. HNO4 peroxynitrile acid. Now they use a common name. Can you quickly post the answer to the chat? There's a book called Vogel textbook of qualitative analysis. So that is very important for your inorganic chemistry. Vogel's textbook of qualitative analysis. If you want, you can I give that name. That was a very good book. Most of the even the university everywhere they use this one. What is that? Vogel's textbook of inorganic chemistry. Vogel's textbook. Right. I'll give the name if you want for your reference. What is that? Vogel's textbook. VOGEL''S. Vogel's textbook of qualitative analysis. It's like a Bible, right? This book. Even the university, the first year, they use this. That is for inorganic chemistry, like your D block, S block, P block one. And this same one, the titration calculation, this is the same book. You have the quantitative also. This is qualitative analysis. That means precipitation, color changes, D block, S block, mostly this is qualitative. You identify qualitatively by color of the precipitate, by complex the color and all. But this the same book, the titration, like the quantitative also there. Quantitative, but quantitative analysis is not that important for A level. But anyway, it It is widely used in the university level. Quantitative analysis. The same one, the quantitative and qualitative analysis. There are two books. You can refer them. Right. There's one more book for used by Professor Dharaniagal. That one I'll tell later. I think that is available in Saraswati also. As I remember, like this bookshops also is available. I'll give that later. Right. Then let's move to the next one. Okay, you didn't tell me that. So what is the answer for this? Did you all post the answer for the fourth? Okay. Tamasha, Vinhara, Ishara. What about from the fourth question? Pramod gave the second answer. Okay, very 2, 3, 4, 2. Okay, so now you have given three answers. Some of you have given the second answer. Vinhara, Prabhu the second answer. Ishara fourth answer. Tamasha third answer. Three different answers now. Question number 4. Right, let's see. Let's see. Okay. How to answer this type of questions? Anyway, you will be getting questions from this dot and cross, Lewis structures, Lewis dot dash, resonance structures, resonance. But so far, resonance hybrid, they have never asked to draw the resonance hybrid. They have never asked to draw the resonance hybrid. Okay. Okay. So peroxynitrile, if you draw the resonance structures, you should quickly draw the resonance structures. No other way of doing this. So I'll quickly draw the resonance structures for this. One possible resonance structure, H O O N double bond O minus H O O N double bond O minus H O O double bond N O minus, then you get H O O N. Right. Now let's see. So this is how you do it. The first one, you get minus charge here. That's the one they have already given. The first one, the one they have already given, I put here. Right. Then here you get lone pairs. Yeah. Sometimes you can get this same question. You can get in the essay also, structured essay also. You can get this. Some of the past MCQs can become upcoming papers, structured essays. Some MCQs. Second one, I'll put this side minus charge here and double bond here. The other one I'll put both this minus and plus charge on these two. Double bond I shift, double bond I am rotating around origin, I am rotating the double bond. That's what I am doing. You should quickly draw the resonance structures for this. Lone pairs also you have to put, if when there's a minus charge on oxygen, there are 3 lone pairs. There are 3 lone pairs. Right. Then the fourth one. Then you put the double bond here and keep all this. So here minus, and here plus charge, and here plus charge. There's a lone pair here. Now these are the resonance structures. These are the resonance structures of this peroxynitric acid. Now you should be able to get the answer. So out of these, which ones are unstable, which ones are stable? Okay, let's try. Out of this hood, okay, tell me the first one is stable or unstable? Most unstable one, tell me. Okay, now 1, 2, 3, 4. 1, 2, 3, 4. Out of these four, what is the most unstable one? Yes, can you put to the chat? What is the most unstable one? There are two unstable ones. What are the two unstable ones? There are two unstable dot dash diagrams here. Structures. What are the two of this table? Two of these unstable. Which ones are unstable? 3 and 4 unstable. Very easy now. So there's a plus charge here. Unstable. This is also unstable. The first two is stable, no? The first two structures stable. This also is stable. This also is stable. Right? So they are asking how many? They are asking how many structures that can be drawn. How many unstable? So the unstable word highlight here. Unstable word highlight. Mostly now see this question is very tricky. Mostly you draw the most stable one in the structure essay paper. Now they are asking unstable one. Unstable third and fourth. Unstable one third and fourth. So what is the answer now? Answer is second. Is that clear? Because of this plus charge is unstable. Because of the plus charge it is unstable. Because of this plus charge. Plus. Here plus. Here plus. Got it? Any questions? Who got the answer for this? Question number 4 answer is second. Answer is second. Ishara, okay. Ishara, earlier you gave third and fourth. Both. Now you have switched to second. Good. Pramudi gave fourth one earlier. Right. Now you have understood. Vinhara also gave. Third and fourth means third and fourth is structure unstable you gave, no? Yeah. But earlier you gave, Thomas gave third answer. Thomas, did you understand now? Answer is second. Vinhara gave second. Ishara gave fourth. Ishara, did you understand? Pramudi gave second. Okay, Pramudi and Vinhara gave the correct answer before I explain. Right, okay. If you have no time to copy down all this, you can take a screenshot, no problem. Or else now I'll upload this to your these papers discussion and all, like the paper class, all the recordings, if you want you can watch them again. Any section if you need like to listen again, you can request the recording, no problem, even though you have come to the class. I'm joining the online session also, and anyway I'll upload in them, because after maybe few months again if you forget any section, then you can refer that part actually the video, because anyway you will forget with time this stuff. So therefore I have created a channel now, YouTube channel, so I'll be uploading them all the recordings to that one, but it's private. I mean outsiders cannot watch it. Therefore you should better send me your email address, then you have to sign into YouTube or the Google accounts using that. There's when you open the dashboard YouTube, then there's a rightmost side top, there's a icon in that your profile icon. So when you click on that, you can you have to sign in using that email. So you have to tell me the email address that you are using your YouTube now or the Google account. So then that one, using that one only you can watch it, right? No need to send the password, only the email address. Then at any time you can watch them again, because sometimes from time to time, because of the you get disconnected and because of the shared screen is not clear. If you have an unstable internet connection, I am sharing the screen but it's like blur, that you can't read properly, then also you have to watch the recording again. So these technical issues, they are during online classes. So therefore that is the second solution, alternative solution for that. Even but the problem is the Zoom cloud recording, it's get deleted within 3 days because of the lack of storage. But then the next alternative, even after 3-4 months, even when the AL exam is closed, you can quickly refer. You can increase the, what is this called, the slides, the speed also you can adjust there when you listen to this recording. Okay, that is question number 4. Question number 5, no need now. IUPAC we have done, right? IUPAC we have finished organic IUPAC nomenclature. Did I discuss this question before? Pramudi and others, did I tell the answer for this?
Yes, sir.
Okay, then no need to discuss that. Then question number 6, again, general and inorganic. Can you tell me the answer for this? Question number 6. Yes. What is this called? Decrease in word highlighted in bold letters. That is bit important. Decrease in order of these ions. Right. Radius, that means size. Radius matters here. Radii means plural. Usually across the period, what happens? So now you should refer the periodic table also, because the position, the periods important. They are periods important. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. First tell me the answer. What is the answer here? If you want, you can mark the position of them in the periodic table, right? So group 7, group 6 elements are there, and group 6 7, all are group 6 7. All these are group 6 7. Group 6 you have oxygen and sulfur, and group 7 you have fluorine and chlorine. Remember, anion is always larger than its atom. That you should know. Anion is always larger than its atom. Anion is always larger than its atom. If you want to write here, O2 minus is larger than O, as well as S2 minus larger than S, and F minus larger than F. But all these they have not given the neutral one. And Cl minus, I didn't put them in order, right? Cl minus larger than Cl, so that you should know. Can you all write here? Anion is always larger than its atom. Anion is always larger than its atom, than neutral atom of the same element. Neutral atom. These are the examples. Anion is always larger because when electrons are added, to an atom, this shielding, that means it decreases. So it's like inertials, that means attraction of the electron towards the nucleus. The effective nuclear charge drops. When more and more electrons added, then there will be more inner electrons. So there will be more electrons. Then it's going to be increase in size. When electrons are removed, it's decrease in size. So that is common sense. Anion always larger than its atom. Okay. So all these are anions. All these are anions. Now one method. Now don't look at this type of questions. Don't ever look at the answers without predicting the answer. You should predict your answer, and then after that you look at the answers given. That's the best thing to do here. Now who is below? So down the group, what happened? It's down the group size radius increase. Right? Across the period radius decrease. So it increases down. It increases downwards. Downwards is increases. Therefore, chlorine is larger than fluorine. Fluorine is larger than fluorine. So I'll write here chlorine larger than Cl minus, larger than Cl minus, larger than Cl. Cl minus larger than Cl. But Cl is not given here. So let's see the neutral atom. Chlorine and sulfur bottom. So definitely this side it decrease. But when the charge increases, like that means 2 minus sign. This also I'll write 2 minus. Okay, I'll put this way. 2 minus is greater than S2 minus greater than minus. 2 minus greater than minus. S2 minus greater than S2 minus greater than Cl minus. Cl minus. So once at the bottom, anyway largest. These two ions larger, so obviously there's one addition, so they should have the highest value. So that I will predict first. Out of those two, what happened? These two are the largest, sulfur and chlorine largest. Out of them also, there are two ions, S2 minus and O2, Cl minus. So out of them, which one is largest? S2 minus. So when the charge, when the radius increases, so anion charge, when the charge of anion increases, radius increase. When the charge of anion increase, right here, when the charge of anion increase, that radii increase. Radii also increase. Charge of the anion matters. Anion is greater than neutral atom, and with the increase of the charge, it's a further increase. When the charge of the anion increase, radii increase. That also you should. That's why in the same period, but that should belong to the, what is the condition here? Same period. Same period. Same period. Okay, that is the other one. If you take nitride N3 minus, that will be even phosphide. P3 minus will be greater than even S2 minus. Understood? Then the other one is what? Oxygen and what are the, okay, these two we have predicted now. These two we have predicted. Then oxygen and fluorine. Oxygen and fluorine, they have given both neutral atoms, and neutral atoms also given, and see this couple. Neutral atom also given, charge also given. Now these two we have predicted now. So that one we will put a right tick. These two we have predicted. Now from these two, who is larger? O2 minus or F minus? O2 minus or F minus? O2 minus larger. Right. O2 minus larger. O2 minus larger. Right. I told you when the charge of the anion increase, its size increase in the same period. After that, what happened? F minus. F minus, because anion always larger than the neutral atom. Anion larger than neutral atom. Then after that, what happened? Oxygen or fluorine, neutral atoms left. Two neutral atoms, oxygen and fluorine, two neutral atoms. So out of them, which one is larger? Oxygen. Oxygen is larger. Neutral atoms, what happened? When you consider neutral atoms across the period, size decrease. And then lowest will be fluorine. Fluorine has the highest electronegativity also. So with this, so this is neutral atoms. Neutral atoms having the lowest. Neutral atoms having the lowest radius. Lowest radius. Then anions with greater charge, highest. Anions with greater charge. Greater charge and down the group. Greater charge, anions down. Down means like the down the group. Anions down the group with greater charge, size is higher. So sulfur is below chlorine. Below oxygen. Right. Is it clear? Did you all get the answer? Question number 6, what is the answer? Earlier, Ishara gave second, now. Ishara, did you understand this? Answer is first one. Pramodi correct, Vinhara correct, Tamasha correct. Okay. Now, best thing is now you are given the periodic table. You are given the periodic table, so you can predict this easily. Right? Okay. Always position of the elements matters, and their charge matters. Position matters, charge matters. That's it. Higher the charge, higher the radius if they are at the bottom of the group. And neutral atoms always smaller than the charged ones. Okay. That's a good question in organic chemistry. Right. The next one. Question number 7, physical chemistry. I'll discuss them. Physical chemistry revision I'll do separately, right? We are doing inorganic and general chemistry now. And organic ones, if we come across any organic questions, if we have done before, so then that one I'll discuss. Then question number 8. Total number of electrons exchanged. That's a good question. Now see, organic chemistry, they are asking oxidation thing and reduction number. Well, see, this is organic chemistry coupled with inorganic chemistry. Organic chemistry coupled with inorganic chemistry. Let's see. Can you guess the answer of the question number 8? Yes, question number 8. Can you guess the answer? Eighth MCQ. Okay, let's see. Question number 8. How many of you have got the correct answer? Aishara not done it. Tamasha gave third answer. What about the others? You didn't do this. Maybe because of you, so organic one, that's why. Actually, this is oxidation numbers. We have done oxidation of ethanol to acetic acid. So they have given. You oxidize. So actually, you don't need organic chemistry here. They are asking how many total number of electrons exchange. That is the question. Total number of electrons exchange. That is what you had done. No, redox balancing chemical equation, chemical calculation part, and the balancing using oxidation number. That's what the equation here. We'll write this directly. Let's discuss. So at the same time, you can try this. This is not organic chemistry. Organic chemistry, they have given what is happening to ethanol. C2H5OH, C2H5OH react with potassium dichromate K2Cr2O7 and form acetic acid CH3COOH. So what will happen to dichromate? In the acidic medium, dichromate becomes Cr3 plus, Cr3 plus, and C2H5OH, and this become carboxylic acid. This get oxidized to carboxylic acid. Right. Most of the things they give the inorganic chemistry the balancing. Now this is one organic chemistry they have given here. Now let's read the oxidation numbers here. What is the oxidation number of chromium here? Plus 6 plus 6. And what is the oxidation out here? You get 2 chromium. Okay, 2 chromium ions because Cr2 need 2 chromium. What is the oxidation number of chromium here? That is plus 3. But how many electrons involved here? How many electrons involved here? It's easy. You can try this. How many electrons involved here? Plus 6 become plus 3. How many electrons involved? For both the chromium. 3 electrons involved for 1 chromium. Yes. For both the electrons, how many for both the chromium? There are 2 chromium. You can try, you can do fast if you want. Now you got the point. How many electrons get exchanged here? 6 electrons. 6 electrons gain plus 6 reduction. Chromium undergo reduction from plus 6 to plus 3, but since 2 chromium in all, plus 3 into 2. I'll write this way then. If you get confused, plus 3 into 2. Plus 3 into 2. That means 6 electrons. 6 electrons. Plus 3 multiplied by 2. The next one. 6 electrons total. 6 electrons total. Then ethanol. What is the oxidation number of carbon in ethanol? What is the oxidation number of carbon in ethanol? Tell me. What is the oxidation number of carbon in ethanol? CH3, CH2OH. Okay, I'll write this way. Then it's easy to find. I'll expand this and write CH3, CH2, OH. What is the oxidation number of carbon in ethanol? Which carbon undergo the change in oxidation number, CH3 or CH2? Who will get oxidized? CH3 no change. CH3 no change. CH3 remains. So CH3 oxidation number no change. So then which one oxidation number has this? CH2. CH2, what is this carbon oxidation number now? Tell me. It has changed. That carbon has changed. CH2OH becomes CH-OOH. How to decide? So this one you should write. CH2OH. This is how you, if you expand this. So inside carbon. Now this side no effect. This side no effect. So here the electrons are, who is more electronegative? Carbon or hydrogen? Carbon is more electronegative. Here also who is more electronegative? Carbon. Right? Carbon is more electronegative. Then -1, -1. Here who is more electronegative? Oxygen. So they are -2 and +1. So here -1, here +1. What is the oxidation? Number of electrons lost or given out, or gain completely or partially. Here partially 1 electron gain, here partially 1 electron gain, -1, here +1. So what is the net value? What is the net value? What is the oxidation of carbon here, ethanol? -1 or -2? -1 or -2, net effect. Here -1, Here minus 1, here plus 1 is all three, then minus 2 and plus 1. This side no effect. Carbon, carbon not attracted either side. What is that? Plus 1. Plus 1. I think most of the students, this part also weak. This redox balancing. Redox balancing. I couldn't do much questions here. That's why, therefore, that's why I thought of discussing this. Redox balancing, we can discuss much questions. Right, now what is the oxidation number of this one now? This carboxylic acid, ethanoic acid or acetic acid, what is the oxidation number? Here plus 1. Here what is the oxidation number of carbon here? Okay, that also you can expand and see. You will get similar questions in upcoming papers, because there are not much questions of this type in past papers from organic and balancing. Actually, they don't ask you to balance, they ask to check the oxidation numbers, that's it. Organic reactions in organic chemistry, they will never ask balancing. Okay, so here oxygen. Okay, now this is the structure, CH3COOH. Now we want to find the oxidation number of this carbon. Now I'll put here this bond. There are two bonds, then here plus 2. Carbon become plus 2. This side oxygen, then it's become minus plus 1. Plus 1. This side 2 electrons are attracted away. Here 1 electron attracted away. Right? Then it's plus 2 and plus this side no change. Then plus 2 and plus 1, what is that? Plus 3. Plus 3. How many electrons involved now? How many electrons involved? How many electrons exchange? So it's minus 1 to minus 1, plus 1 to plus 3. Plus 1 to plus 3 means how many electrons involved? Yes? This is minus 1. No, sorry. This is minus 1. I had done a mistake here. This is minus 2 and minus plus 1 is minus 1. This is minus 1, not plus 1. Please make that correction. This is minus 1. Here minus and plus. Minus 1, minus 1. Minus 2 and plus 1, minus 1. Okay. So then, what is the change? How many electrons involved here? How many electrons involved here? This is oxidation. So that is why we use oxidizing agent. Oxidation occurs here. So when during oxidation, how many electrons are lost? 4 electrons are given out. 4 electrons are given out. Then total how many electrons involved? Now I'll highlight this. So here the 4 electrons involved. Here 6 electrons involved. 6 electrons involved. So the total, now the question is what? Total electrons exchange. How many electrons total exchange? Total electrons will be 10. Total 10 electrons involved here, exchange. So the answer is 3. Answer is 3. Is that clear? Wait, this is 4 plus 6, 10, no? You get here chromium 6 plus 4, 10. You have to do the balancing also, sorry. Balancing we didn't do it. After balancing you have to check the electrons again, sorry about that. Balancing also we have to do. Total number of electrons, oxidation. How to balance this now? How to balance this equation now? Which reaction? Okay, answer is not 3. Wait. We have to balance and check it, because electrons are. So this equation I'll multiply by what? This equation I'll multiply by 3. This equation I'll multiply by 3. And the other equation I'll multiply by 2. Then the electrons get balanced. Electron balancing done by multiplying this by 3 and that by 2. Why this multiplied by 3 and 2? Then both side electrons become 12. Electrons exchange 12. Okay. 12 electrons. Chromium, ethanol give away 12 electrons. Ethanol give away 12 electrons. Total electrons 12 here. Is that clear? It's a very good question. Recently they haven't asked this type of questions in papers. Total involved here 12. Total 3 into 4, 12 electrons. 12 electrons total. Total 12 electrons. And here total 12 electrons. So 12 loss, 12 gain. Is that clear? Any questions? Do you want me to explain? Total 12 electrons involved. Right. Total 12 electrons involved. Here total reduction, total electrons 12. Here also total oxidation also 12. So what is the answer now? Answer is 4th. Answer is fourth, not 10 electrons, 12 electrons involved. Is that clear? Answer is fourth. How many of you got the answer? None of you. Vinhara gave the answer. Vinhara gave the answer fourth. That's all. Vinhara, did you understand this? Did you balance like this and got it the answer? Then it's really good. Okay. So please copy down this, everyone. Please copy down this, everyone. Very, very important. So electrons loss and gain must be balanced. Electrons loss and gain must be balanced. And one more thing I want to write here. Who make this ethanol get oxidized? That means ethanol becoming carboxylic acid is an oxidation process. So this is vinegar industry, vinegar production. How do they oxidize now? Vinegar industry, I don't think they will put potassium dichromate to production of vinegar. Now this is laboratory method. In the laboratory you can convert ethanol into acetic acid or vinegar by using the potassium dichromate. But the problem is you get a byproduct here, chromic acid. Unreacted dichromate can be present. Chromium is toxic metal. Right? Chromium not good to our health. But natural vinegar, how this is done? They use acetobacter bacteria. The bacteria also doing the same process as potassium dichromate. Acetobacter bacteria can oxidize ethanol into ethanoic acid. So same what we are doing in the chemical laboratory, chemistry lab, acetobacter can do natural environment. So that is called natural vinegar. Natural vinegar. Is that clear? But this is a bit expensive now. You have to remove the unreacted dichromate and byproducts chromic ion. You have to remove if you want to get pure acetic acid. It's a nice question. A lot of things you have to. Not the answer for only for this question. So a lot of things. And who is the oxidizing agent now? Below chromate, potassium dichromate or acetobacter bacteria will be the oxidizing agent. Oxidizing agent undergo reduction. Oxidizing, that is the agent which makes ethanol oxidized. Who make ethanol oxidized? By this agent. Who is that agent? Oxidizing agent will be potassium dichromate. And ethanol will be the reducing agent. Ethanol will be reducing agent. And this reaction is carried out in the acidic medium. Any questions? Is that clear? And this also you should better copy down. Okay, this I'll highlight them green. How to predict the oxidation number in organic compounds? I'll highlight both in green. You should know how to find the oxidation number of simple organic compound, not like paracetamol, aspirin, dispirin, or this glucose, sucrose. So they don't ask those very complex molecule to predict the oxidation, but simple molecules, aldehyde. So then you can check what becoming ethanol into carboxylic acid is oxidation or reduction. You can check. That's why we call it this acid of oxidizing bacteria. Bacteria can helps to oxidize this. Okay. That's why you get when this get oxidized. What is oxidation? What is the meaning of oxidation? Oxidation can be explained as increasing of the oxidation number. What are the other aspects of methods of explaining the oxidation other than increasing of the oxidation number, decreasing of the oxidation number, reduction, increasing of the oxidation number, oxidation? Other than that, if someone combine with oxygen, that is also called oxidation. If someone lose oxygen, that is reduction. Please write it. What is oxidation? Increasing of the oxidation number. Combining with oxygen, losing of electrons, and hydrogen also you can incorporate here. Hydrogen, losing of hydrogen. If hydrogen combine, that is reduction. Sorry, combining of hydrogen, oxidation. Losing hydrogen, reduction. Losing hydrogen, combining oxygen. Shall I erase that? Shall I erase this? Did you all finish writing? Please raise the hand. Anyone still copying down this? Shall I erase this? Okay. Then what are the, so oxidation means, how to define this? Oxidation can be increasing of the oxidation number. Increasing of oxidation number. That means F2 plus become F3 plus. Or you can write losing of electrons. Losing of electrons by an atom or ion. So example, sodium become Na, sodium lose 1 electron and become Na plus. So ionize. That is also oxidation. Then combining with oxygen. Combining with oxygen. Combined with oxygen. That means that carbon combined with oxygen to produce carbon dioxide. Then the other one is losing of hydrogen. Losing of hydrogen. Losing of hydrogen also can be considered as oxygen. I'll give one example. If you take CH2 double bond CH2 and it become CH triple bond CH alkyne. So this 2 hydrogen loss, 2 hydrogen loss. You can check the oxidation numbers here. You can check the oxidation numbers here. Here what is the oxidation number of carbon? And here oxidation number of carbon. Check. This one will be minus 2. This one will be minus 1. So oxidation number has increased. Oxidation number has increased from minus 2 to minus 1. That is called oxidation number. Oxidation number has increased. So therefore this is more electronegative. When the oxidation number increases, it becomes more electronegative. This carbon is more electronegative. This carbon is more electronegative because oxidation number is higher with compared to in alkyne, the carbon is more electronegative than alkene. Alkene, if you take CH3, then it will be, what is the oxidation number of alkane? It's really important. You can get similar questions in the future because they can combine the question this way also. I will write here CH3. So I'll write here CH3. What is the oxidation number of alkane, ethane, carbon oxidation number? It is minus 3. So minus 3 become minus 2. Minus 2 become minus 1. So all this what? Alkane become alkene, that is oxidation. Alkane become alkene become alkyne, that is also oxidation because oxidation number increase. So it can be from minus value, minus 1 to 0, 0 to plus 1. All this oxidation. Is that clear? What are the 5? Now I gave 5, no? 5 methods. Altogether the 4 methods. Increasing of the oxidation number, losing of electrons, combining with oxygen, or losing of hydrogen. All these are called oxidation. Any questions? Reduction is opposite. Reduction is same thing opposite. What is reduction? Decreasing of the oxidation number, or gaining of electrons, or gaining of losing of oxygen, or gaining of hydrogen. So lithium aluminum hydride LiAlH4, it acts as reducing agent. In organic chemistry, LiAlH4 acts as what agent? Reducing agent. Why? It can supply, it can release hydrogen, and the other part can get, if say example capital A can combine with hydrogen. So A undergoes what? A undergoes A goes with hydrogen. A undergoes reduction. No, A undergoes reduction. So that is, this is the agent. This is the agent which makes A to reduce. Therefore, this lithium aluminum hydride called what agent? Reducing agent. It is reducing agent. There are oxidizing agent as well as reducing agent. So potassium permanganate. Potassium permanganate KMnO4. When it oxidizes, what happened? It becomes Mn2 plus. You have done this one, no chemical calculation. Mn2 plus. So this one, what happened? Oxygen is lost. Oxygen, losing of oxygen is what? Losing of oxygen is reduction. So the permanganate has undergone reduction. If you want, you can tell this using oxidation number. Plus 7 become plus 2. Plus 7 become plus 2 means reduction, or losing of oxygen reduction. So therefore this considered as the one who reduce become the oxidizing agent, because that oxygen lost by potassium permanganate combined with someone else. Okay. Now, no wonder, can you remember these milk powder packets? Empty space of milk powder packets, they fill nitrogen gas. Ne? Why don't they fill atmospheric air? To prevent the oxidation of food. Empty space of milk powder packets, the entire inside the this plastic, what is it called? The cardboard, no? It's inside the cardboard box. Again, there's a container, like a polythene. Inside polythene container, there's you have milk powder. So this space is filled with nitrogen gas. Here the bottom milk powder. So why don't they keep this normal air? Normal air contain oxygen. Food get oxidized. Milk powder get oxidized. So oxygen can make the food oxidized. Then the change it changes. So you come, what happened? Curd become sour taste. Amul rasa. Milk become sour taste when it gets spoiled. So that is due to the oxidation of food or the various components inside. So oxygen containing environment. So this is very, very important. I think definitely you will be getting similar questions in upcoming papers, right? Because so far they haven't asked this redox thing with link with organic chemistry before. Okay, then shall I erase this? Anyone still copying down? Anyone is still copying down? Okay, then I'll erase this. But this is 2020 paper, so therefore this 2020 and 19 paper, I strongly advise you discuss all the questions in detail in 2019 A level 2019 and A level 2020. Please discuss the papers in detail. Please discuss, please refer all the essays and structured essays. Discuss them in detail. Because you can get similar patterns of questions in upcoming papers, because your syllabus, new syllabus started in, the paper started in 2019. New syllabus paper started in 2019. That's why. Okay, let's move on to the next question. Now next one, this also actually aldol condensation, we didn't discuss this yet, so therefore I will discuss this later under aldehyde reaction. KSP physical chemistry. Next question we can do, what is this? Consider the compounds boiling point. Okay, let's see that one also. Next one, question number 12. Increase in order of the covalent character. It's a good question. Yes, can you tell me the answer for the 12th MCQ? 12th MCQ, the answer. This one, inorganic chemistry. Yes. What is the answer for the 12th MCQ? Do you have this paper, right? 2020 paper. I think I also posted to your WhatsApp. If not, tell me if you don't have it. Yes. Now anion also different, cation also different. Best thing to do is this. You can write the position them in the periodic table. Who is most electronegative? Most electronegative is fluorine. I'll write fluorine first. Second highest, chlorine, Cl. Third highest, sulfur. Fourth highest, sodium. Then the least electronegative, potassium. So increase in order of the covalent character. Increase in order of covalent character. Increase in order of the covalent character. Now, so let's see now combine. If I combine this, potassium fluoride, Kf, and KCl you can compare. Now they are given KCl and Kf. Now you can take this easily. Here KCl, KCl. And then there goes sodium sulfide, Na2S. The other one is NaCl. The other one is NaCl. Sodium chloride, NaCl. So which one has the greatest distance? What is the longest distance? Check the longest distance. Which one has the longest distance? Longest electronegativity difference. Highest electronegativity difference. That has the lowest covalent character. Higher the electron, higher longest one, this. Which one has the longest gap? Longest gap. Longest electronegativity difference. So the largest. I will largest, greatest. Largest difference. Largest gap, KF. So KF has the lowest covalent character. I'll write now the order. KF has the lowest one. Now this kind of question, my advice, if you can't directly see the answer, at least predict the lowest and the highest one. Then you can filter. Did you get, if you are a little tricky, you can, you know, who is at the, okay. Down the group electronegativity, decrease ne. Potassium lowest ne. Here this corner who has highest? Fluorine. Therefore when KF combine, that is most ionic ne. Most ionic. Most ionic. Here the lowest electronegativity difference, lowest electronegativity, here highest electronegativity. Out of these ones, highest electronegativity. Anyway, fluorine is highest. Highest, I put En. Highest electronegativity fluorine. So therefore KF will be the most ionic. That means least covalent. Least covalent. Most ionic means least covalent. KF will be lower. So that way you can predict. So which pair is very close now? Sodium and sulfur. Sodium and sulfur, Na2S. That has the KCl. Then second longest one, KCl. I put the number in, then it's easy. I'll put the number in. Number one, longest this. Second largest difference, KCl. So KCl come next. Okay, I'll write here KF, KCl. Next one, next highest, NaCl. I put number 3. That means highest electronegativity difference. That is NaCl. Next one, what is the most covalent one? Lowest electronegativity difference. Number 4. Number 4 is what? Na2S. Is that clear? So I can do this fast, but so that everyone, I explain this so that everyone will understand this. So therefore you have to be little tricky when you are given that, when they make you confuse you, I mean in other words what, they give a set of thread like entangle, like it's like mess up. Then you filter, you separate, you make it more simple. They make it complex, but we make it simple and get the answer. That's what I have done here. Okay, how many of you got the answer? What is the answer now? What is the answer? Which one you get? Now this type of questions, my advice, don't look at the answers. At least predict the lowest one, or at least highest one. Then you can get an idea rather than marking one out of this. Let's see now your answers. If you have any questions, you can ask. So Pramodi gave the correct answer, Ishara gave correct answer. Only Pramodi and Ishara gave correct answer. Vinhara, Tamasha, did you understand now Vinhara and Tamasha? Ishara, earlier you gave second answer and then third, right? Anyway, Ishara changed the answer. When I start explaining, then halfway, then you change the answer. Good. That means you have understood that when I halfway through when I explain halfway through, some of you are changing the answer. That means you have understood it good, right? At least now. Okay. So this is now when you get a similar question again, follow this method. Write them like this according to the increase in or decrease in order of electronegativity. Electronegativity values are not required. You should know the position of them in the periodic table. Highest electronegativity, fluorine and chlorine. Group 7 elements having the highest, lowest group 1 bottom. That also you should know. Highest group 7 top, electronegativity highest group 7 top, lowest group 7 group 1 bottom. Group 1 bottom lowest. Group 1 lowest, that also lowest bottom. So remember both electronegativity and ionization energy lowest group 1. Group 1 also bottom. Again I am repeating that word. Both electronegativity and ionization energy lowest group 1. Group 1 also bottom. Electronegativity highest group 7 top. Ionization energy highest group 8 top. If you don't know these basic things, you should better copy down in a short notebook. Again I am repeating. Electronegativity highest group 7 top. Ionization energy highest group 8 top. That means electronegativity increases only up to group 7. Ionization energy increases up until group 8. The lowest, both lowest group 1 bottom. Ionization energy also lowest group 1 bottom. Electronegativity also lowest group 1 bottom. That means down the group both decrease. Write these things because they don't give the values. Numerical value of electronegativity or ionization energy not necessary if you know the position and the trends. If you know the trends of this ionization patterns, ionization energy and electronegativity in the periodic table, you can easily get the answer. Down the group both decrease, across the period increase, but ionization is zigzag pattern, electronegativity gradually increase, approximately gradually increase. Electronegativity increase only up to group 7, ionization energy increase up to group 8. Any group down the group both decrease. Any group there are some small fluctuations, but other than that, it's general. Right? Is that clear now? Any questions? Any questions? Anyone still copying down? Please raise the hand. Right. Then I'll erase. Question number. After that, question number 14. This is a calculation. Have you all done this 14th MCQ? Please raise the hand those who have answered the 14th one. Tamasha done, okay. And what about the others? Didn't do. It's a calculation here. Electric furnace. They have given the. Okay, I'll write here. 62 grams, no? 62, I'll write here about this. 62 grams calcium phosphate. Oh, sorry, 620 grams. 620 grams. 180 grams. Silicon dioxide 96. 96 carbon. Right. Now, if you divide this by molar mass, then you get the number of moles. Okay, I'll write quickly here. Calcium phosphate Ca3 PO4 twice. So what is this? 620 grams. If you divide this by what is the molar mass, so I won't waste time, you get 250. If I'm wrong, tell me. 250 grams of the calcium phosphate molar mass. So how many moles are you getting here? 2.4 moles. 2.4 moles. Then here 3. So here 2. Then silicon dioxide 6 SiO2. Right. 6 SiO2. So how many grams here? 180 grams. Convert that into moles. How to convert this into mole? Divide by 60 grams per mole. Then you get how many moles? 3 moles. 3 moles. Then plus carbon 10 carbon. How to convert this into moles? 96 divided by 96 grams there is, I will divide this by 12 grams of mole. Then you get the answer. How many moles? 8 moles. 8 moles. 8 moles. 3 moles. 2.4 moles. So the mole ratio we got now. Then you get P4. Now the question is about P4. I'll write only P4 because others not interested, because P4 they ask. They are asking yield, percentage yield of P4. This percentage yield very important. Please put 3 stars. Please put 3 stars for the percentage yield, because no, I mean it's something new, like, because past papers they haven't asked this much. Therefore upcoming papers they can ask this percentage yield again. P4 the product. Now P4, how many grams they have got? 50 grams. 50 grams P4. Then I'll write here 50 grams divided by, what is the P4, what is the this one, 124. 124 you can get 31 into 4 grams of mole. And how many moles are you getting here? 0.4 moles. 0.4 moles, right? 0.4 moles. Now what is percentage yield? So what is the stoichiometric? 1:3:5. If you get the simplest ratio here, what is the simplest ratio? The smaller ratio here, 1:3:5. 1:3:5. The molar ratio, simplest molar ratio. So that is the stoichiometric values, but actual values we got what? This ratio. So here 1:3:5. And the other one you get here, so you get 2.4 into 3 into 8, right? That is what we got now. That is what we got now. Now the question is, which one is the limiting agent now? Will all these get reacted now? That's the problem. We mix that much of grams, will everything get reacted? So we are supposed to get 50 grams. So we got 50 grams. Actually we are supposed to get how many grams? How many grams? P4 also we should get 2 moles now. We got here calcium phosphate 2610 and P4. So amount we got 50. 50 divided by what? Into 100. 50 divided by, so how many we are supposed to get? P4 actually. From 1 mole, 2 to 1, 2 moles give 1 mole. Then 1 will give 0.5. 0.5. 1 gives 2 calcium phosphate give 1 mole. 2 calcium phosphate give 1 mole. Then 1 calcium phosphate moles will give 0.5 moles. They are asking under the conditions the limiting reagent, it's completely consumed. This is very important. I'll highlight that. Limiting agent, now we have to find limiting agent completely consumed. For based on that we have to decide the P4 yield. P4 yield. Now who will be the limiting agent in this reaction? Based on the so you should get this ratio here 1:3:5. Will we get 3 times here? No, we don't get 3 times. 2.4 into 3 times will be what? You get 3 times 2, 3 times 4, 12, then 7. You actually you need 7 times here. So if you multiply this by 3 times, so you get more than 7. And this should be 5 times. So that means what? Out of this, which one will be utilized first? That's what I'm asking. By looking at this ratio, who will be the limiting reagent? That means who will finish first? That become the limiting reagent. That you should know first. So silicon dioxide we have is 3. From 3 we need only 1 mole from this. 1 mole we require this. To react with 3 moles of silicon dioxide we need only 1 mole of this. But there are 2.4. Therefore SiO2 will be the limiting agent. Now can you understand that? SiO2 will be the limiting agent. SiO2 will be the limiting agent. Okay, now is that clear, everyone? If 3 moles of silicon dioxide get reacted, calcium phosphate will be 1 mole, because 3:1 the ratio. 3:1 the ratio. Here we have used 3 moles here. Here 3 moles used up. Here look at the equation. 3. I put a right tick here. Right. So limiting reagent completely consumed means that you can check the total grams of limiting reagent. If 6 moles gives 1, look at now. If 6 moles gives 1, 3 moles will give what? Calcium phosphate. 3:1. 1/6 into 3. 1/6 into 3. That means 0.5. 0.5 moles you are supposed to get here. 0.5 moles you are supposed to get. So then actual amount that you are supposed to get P4 is what? This is what we got. This is what we got. 0.4 moles. 0.4 moles means how many grams? This is what we got. 0.4 moles multiplied by what is P4? The total will be 124, no? Then what is the grams? How many grams we got? No, that is we already be there. No, we see 50 grams we got. That is no problem. Yeah. So 50 grams we got here. That is what we got. Received. Actual amount received. Actual amount received. But we are supposed to get how many grams? 62 grams. We are supposed to get 62 grams. How to get 62 grams? We are supposed to get, should get actual amount received, expected amount. The expected amount will be P4, what is the molar mass? 124. 124 into 0.5 moles. Then you get 62 grams. And now you should know how come this 0.5 moles. This much of moles we should get according to the limiting reagent. Right? That's why I explained here 3 moles, and here 6 to 1, then 3 to 0.5. Do you understand what I'm saying now? According to the balanced chemical equation, 6 moles of silicon dioxide gives 1 mole of P4 ne? But we are using 3 moles ne? From 3 we should get 0.5 moles. We are supposed to get 0.5 moles. Can you understand that? From 6 according to the balanced chemical equation, from 6 we should get 1 mole. 1 mole. But we are using less than that. From 3 we will get 0.5. Is that clear? We should get here 0.5 moles from 3 moles. 3 moles of silicon dioxide get utilized. Then P4 we should get 0.5 moles. Can you understand that? Very simple logic. Yeah, this question you might not believe. A-level mark in the performance. I will show you now 2020 the students the performance, the MCQ. This is very low the pass rate. I'll show you the examiner's report now after this. Let's see now. This question is hard. It takes time. Most of the students they have not done this properly. Okay, so I'll draw an arrow here. Actual equation 6 to 1. 1 mole here 1. But we are using 3. From 3 we should get 0.5. Can you understand that? That is one important thing. That's why I multiplied this by 0.5 moles. Can you understand that? Here I put 0.5 moles. Look at here. 0.5 moles into 100. What is the molar mass? 124. No, here 124. P for the relative molecular mass, molar mass. So that's how. Now we can tell this is what we expected, this is what we got. Then what is the percentage yield? 50 divided by, from 62 grams, we are supposed to get 62 grams, but actually we got, I'll write this leftmost side corner. We are supposed to get 62 grams, but we got here 50. Then multiply this by 100%. Then you get the percentage yield. Can you do this calculation and tell me the answer? We are expecting 62 grams, but actually we got 50. What is the percentage yield? What is the percentage yield? Yes, 80.64. You get around 80.64. So we'll get the approximate value 80. Silicon dioxide and silicon dioxide is the limiting reagent. Limiting reagent we found silicon dioxide. So that one from silicon dioxide we get P4 80.7 the percentage yield. 80.7, 80.64 you get 645. So this is approximate you get here 80.7%. 80.7%. Is that clear? Before, please be honest. So please raise the hand those who got this answer. I'll highlight this the last part. This is the last part, the calculation. Percentage yield. Percentage yield. So far, any A-level papers, this percentage yield they haven't asked before. Percentage yield they haven't asked before. Before they haven't asked. This is the first time they asked this. That's why I took this question was hard. Therefore, I hope upcoming papers they might ask this again. Percentage yield. Actually, this is given in London A level, Edexcel and Cambridge both. I will show you that also if you want. Now they atom economy and percentage yield, and they lot of things other than this. So how effective your industrial process, you can decide this. If you mix the raw materials in this proportion, the grams, you can tell whether you are productive your business or not. Otherwise you are wasting so much raw material because they are not unreacted raw materials. Silicon dioxide only completely used up. Randomly you can't mix the like making a cake the way the things you want, right? Because the quality of the product, if it is a pharmaceutical industry, imagine instead of phosphorus P4 you are going to make paracetamol or vaccine here. Then you need the any industry you need the raw material. If you don't mix the raw materials in right proportion, what problem will arise? Unreacted raw materials will be left in the I am telling now the applications of this calculation. Otherwise you not only for the exam, industry this is very important. Unreacted raw materials left with the product, quality of the product low, then you can't market that product. You will, if it is a medicine, you will get a lot of side effects, right? So you have to mix the raw materials in the right proportion. How to find that? By balancing the equation. Then you get the molar ratio 2:6:10. Simplest ratio 1:3:5. Look at this equation. Balancing. If you don't balance proportion, now the ratio go wrong. Your raw materials, the proportion or the that also will go wrong, and your product lot of unwanted, and you are wasting raw. Not only the quality of the product, you are wasting raw materials. Production cost increase. Production cost is high. Quality is not good. So you will lose the business. Who predict this quality assurance? Chemist. This is on the hand of the chemist. If chemist is doing a mistake, entire process they will lose the business. Then the commerce and accounting come later. So you should have a good business to do the commerce. I mean, to balance in the profit and all this. So all this accounting and commerce. So but that all based on the product that you make, right? Quality of the product and the how effective your production process and how productive your process. Right. So this is really a nice question. So because a lot of applications on this you can get. Right. So any doubts? If you want me to explain any part, tell me again. What is the answer now? Answer is second, no? Who gave Tamasha gave the second answer, and Vinhara second attempt gave the correct answer. Answer is second. Good. Others, did you all understand? Now question number 14. I will tell you 2020 A level the performance the examiner's report. Okay, shall I erase this? Did you all copy down everything? Or if you want me to explain any part, tell me again. Now the students can okay, sure, I'll brief it again, don't worry. Right. Okay, let me explain now. I will use this entire. Okay, Ishara asked me to explain this again. Look at this. Can you see now this screen? Okay, what is the reaction? This is the reaction. This reaction, the balance equation, what? 2 is to 6 is to 10. That is the ratio they react. If you mix your raw materials in the same ratio, 1 is to 3 is to 5, 1 is to 3 is to 5, then you get the product, right? 1 is to 3 is to 5. That means what? You put 10 moles of calcium phosphate, 30 moles of silicon dioxide, and 50 moles of carbon, right? So that, or else you get 20, 60, 100, like that, or 2000, 6000 and 1000. Okay, so you have to mix the moles. That is the mole ratio. So that is the mole ratio they react. But actually we are mixing what moles? I have highlighted here the black ones. This is what we mix. 2.4, 3 and 8. Now silicon dioxide, anyway 3 getting used up here 3 minimum 3 moles required silicon dioxide. Then what happened? That is called the limiting agent. Limiting agent means the one who get utilized completely. That means it's not enough. The others are left, others are in excess. That's what it means. So silicon dioxide completely get utilized. From 6 moles of silicon dioxide, you get 1 mole of first. What is the first step? You have to find the limiting agent. Limiting agent you have to find first. Then from the that is the first. I'll write the steps. Limiting agent you have to find first. Then you find from the limiting agent moles. You find the limiting agent moles, and you find expected products moles from this limiting agent. If you find the limiting agent, you can see the moles. 3 moles added here. Limiting agent you put 3 moles. Then the expected moles of products. Expected moles of product will be expected moles of product means P4. How many moles we should get? 0.5 moles, because 6 moles gives 1. Look at the balance equation. 6 silicon dioxide moles give 1 mole of P4. Therefore 3 moles should give 0.5 mole of product. P4 0.5 moles you should get from 3 moles. But then 0.5 moles means how many grams? Multiply P4 is what? P4 means what is the molar mass? 100. What is the 124? Then we should get how many grams we should get? 62 grams we are supposed to get. From 3 moles of silicon dioxide we should get P4 0.5 moles. 0.5 moles of P4 means 62 grams product we are expected to get. But actual amount we got what? 0.5 moles. That means what? 50 grams. Sorry, 50 grams they have given. They have directly given in the question 50 grams. We got 50 grams. 62 grams we are expected to get, but we got 50 grams. Then what is the percentage yield? Amount product, the actual amount divided by the expected amount into 100%. What is the percent? Write the equation for the percentage yield. What is the percentage yield? Actual amount divided by the expected amount into 100%. That's what we. Okay, is that clear? Now you have to find these moles. 3 moles you have to divide by grams, you have to divide by molar mass each, and you have to write under this equation. You have to write the actual moles you mix, and this is the expected, the actual moles you are supposed to mix, 2 to 6 to 10, but you have mixed this way. Understood now? Who asked that question? Is that clear now? Ishara, no? Ishara, any more part you want me to explain now? Okay, right. Now I will show you what is this question number. I will erase this, right? It's a good question. You can definitely get a similar question again, because before the percentage they haven't asked. Now question number 14. Let's see the performance of the candidates A-level paper. Then you will understand how important this question. Now the chance of repeating this again. I think I had the examiner's report. I'll check. I think I had. Past paper examiner's report 2020 A-level examiner's report. Performance of candidates. Okay, A-level 2020 performance of candidates. Look at this. I think chemistry paper, the examiner's report. I think chemistry paper they have not given separately. I think chemistry They give yeah, that one I know. The only the performance examiner's report they will give percentage. Definitely, I think it's not published yet. I think chemistry is 6 point. Yeah, that is this one. I'll show that later. Right. Okay. That is question number 40. Each MCQ they evaluate how many the percentage of correct response. This one physical 16th organic. This is energetics. Question number 18. De Broglie wavelength of neutron traveling the velocity is lambda. Kinetic energy of phase equation is increased 4 times. Neutron is increased 4 times. Right. Neutron, the velocity increased by 4. Kinetic energy increased by 4 times. Okay, that's a small calculation. Kinetic energy of neutron increased by 4 times. Right. New de Broglie wavelength. New de Broglie. Okay, can you tell me the answer for this? 18th MCQ. That is from general chemistry. General chemistry. Yes, calculation and general chemistry. What is the answer for this? Question number 18. 18th MCQ. Can you quickly post the answer? Vinhara gave the answer 4th. What about the others? Tamasha gave 2nd. Others? Vinshara also gave 2nd. Pramadi? Any guess what I have done? How to do this? Okay, let's see. Yeah, most of you all gave the answer. Actually, the answer is first one, right? Answer is first one, not second. Answer is first one. Lambda over 2. Let's see how to do it. Answer is first one. Let's see how to do it. Answer is first one. They have given kinetic energy equation. Look at the screen now. Okay, I'll work out quickly. Right. So you get here E equals kinetic energy equal half mv square. Half mv square. Now kinetic energy increased by 4 times. Energy increased by 4 times. That means what? It become half mv squared into, so it's 4 times 4 times increase energy. That means what? Half mv squared into 4. That means half into 2v squared. Can you understand that? Half m into, I put like v squared is v squared into v squared. I'll simplify this. When you multiply this, you get like this. Half m into, if you multiply this, so you get here half m into 2v squared. 2v squared. 2v squared like this. Then that means what? When velocity become 2v, can you see, if you look at this, if velocity become 2v, when velocity become 2v, right? When velocity become 2v, energy, then energy increase by what? Because it's 2v squared here, v squared. V squared means what? When the velocity become 2v, v squared means what? 2v squared. Then you get here 2v squared. This is what you should understand. 2v squared, that means what? half mv squared ne? Half m 2v squared. So velocity become double. When velocity become double, kinetic energy become 4 times. Can you understand that? Then only it become 4 into half mv squared. Can you understand that? So then energy become 4 times. If velocity is double, energy become 4 times. That's what you have to understand here. When velocity is double, 2v energy become 4 times. That you should understand here. When velocity of the neutron become double, kinetic energy become 4 times. Kinetic energy become 4 times. So what you should do? Velocity to make, if you want to write this, to make energy kinetic, to make kinetic energy 4 times, because neutron mass won't change, mass won't change, only velocity should change. To make kinetic energy 4 times, velocity of the neutron should be double. That's what you have to understand here. To make kinetic energy 4 times, velocity of the neutron must be double. 4 times velocity of the neutron must be double. Can you understand that? Velocity of neutron must be double. Must be double. Okay. Now, that's why I wrote here 2v. Can you understand that? Why did I put here 2v? Otherwise, you will not understand this. Otherwise, it's like magic. No, you might understand. So, to make kinetic energy 4 times, velocity must be double. Is that clear? Everyone? Must be double. That's why I put here velocity 2v. Is that clear, everyone? Okay. Now, let's move to the question now. What is this? A de Broglie wavelength. De Broglie wavelength. Right. What is the equation for the de Broglie wavelength? Lambda equal h over mv. This is the de Broglie equation. This is the de Broglie equation. Now we will apply the values to this. Now let's see when we make the kinetic energy double. Let's see lambda equal lambda a. We don't know that lambda a. I'll put h over mv. Now I have two equations. This is the first initial equation. This is the next equation. You can divide these two. You can divide these two. So when the kinetic energy change, I'll mark. Now this is the initial lambda. So I put lambda a as what? New wavelength when the kinetic energy of double. When the kinetic energy is double. So this is the first equation and the other one is the second equation. When velocity is v, that is the wavelength lambda. When velocity is change, now we apply 2v here. Very easy. Nothing is very easy. I don't have space. Shall I erase this part? Shall I erase the right hand side? Now I had put here 2v, m into 2v. M no change, then is 2v, velocity is double, here 2v. When velocity is 2v, then lambda we will check lambda a. We don't know that. That's what we are going to find. Shall I erase this? Okay. Right hand side, you understood the logic, right? When velocity double, to make the kinetic energy 4 times, velocity must be double. You understood? Okay, I'll erase that. Otherwise, you must be wondering why did I put within bracket 2v. Right. Now, I'll divide this. These two equations. I want to find lambda a, new de Broglie wavelength. Right? New de Broglie lambda a. I want to find now. Now I'll divide 1 divided by 2. 1 over 2. Or I can take 2 over 1. Okay, I'll make 2 over 1 because I want to find. I'll make it easy. 2 divided by 1. Then I will get directly lambda a divided by lambda equal h over m2v divided by h over mv. Right. Then I can take the reciprocal of this, h over m2v into I can take multiply when it become mv over h. So then it get cancelled. Then I can tie it here lambda equal lambda a. That means de Broglie, I put lambda into lambda, I like this side into the lambda. Now mu get cancelled, this mv cancel, no, mv cancel, 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 mv cancel. What is the answer? What is the answer? Now you can easily get the answer. What is that? Lambda a equal lambda divided by 2. That's how you get it. Is that clear? This is one turning point here. How did you get 2v? Why did you put the velocity 2v when to make the kinetic energy 4 times? To make the kinetic energy 4 times, velocity must be double. That's it. So from that we got this equation. Understood? How many of you got the correct answer with this understanding? With this understanding, how many of you got the answer lambda over 2? Any questions? Right. Shall I erase this? Anyone still copying down? Anyone still copying down? Shall I erase? Okay. So what is the answer? Answer is first one. Answer is first one. Right? Answer is first one. So remember question number 18, none of you have got the answer. Is that, now tell me, do you want me to explain again this? Or are you okay? Tell. If you're okay, so tell. So, okay. Or else if you want me to explain any part, if you have a small doubt in the middle, tell me. Otherwise no point of doing the revision. Just to give the answers, no need to do this paper. I mean, no need to do a paper class, just to give the answers in the marking scheme. I can post the marking scheme also with the paper. So therefore, alright. Now this also bit important. I'll stop share now. This percentage yield, I'll put this reference for the reference. I'll send this London books. They use this percentage yield. Okay, percentage yield they use in London A level and Cambridge and Excel. At the beginning they'll do this at the beginning of the course. At the beginning of the course, percentage yield, enthalpy, give me a second. Science. Yeah, it's there. I will send this. There's a small that one I'll WhatsApp to you. I'll WhatsApp that one. How to find this percentage and stuff that they have given here, right? Excel one. And Excel student book 1 and 2. Book 2, book 1. I think they had to. Yeah, I'll send this to your WhatsApp. The further calculation from percentage yield, the further calculation I'll send you. I'll take a screenshot of what that only those few pages of the Cambridge and Excel I'll send. Then you can refer that, right? So I definitely you have to practice few more questions from this percentage yield, because no possible questions from this. Okay, right? Then next question. Next question. It's there. I check now. It's there. I will forward this Excel and Cambridge one. Right. Okay. Next question. Question number 19. We can't do yet. Carboxylic acid and ester. That also we can't do yet. Incorrect statement. That is inorganic chemistry. What about this 22? 22 shall we try? That's from P block, S block and everything they have combined. Can you guess the 22nd the answer? 22nd MCQ, yes? 22nd the answer? What is the answer for the 22nd MCQ? Yes, in the incorrect one, be careful the incorrect statement. Incorrect statement. You know very easy. So you can directly you can see the answer. Very easy. 20-second answer is very easy. Only Pramodi gave the correct answer. All the others give the second answer. I don't know why. Didn't you see my the P block short note? Didn't you check my P block short note? I have posted this to your WhatsApp. Answer is 5. Aluminium is inert towards nitrogen gas even when heated to a high temperature. That is completely wrong. Question number 22, answer is 5. Okay. Now, what are the elements which react directly with nitrogen gas? Even if you heat them in the atmospheric, they react. Diagonal relationship. Magnesium and aluminium form both nitride. Okay, wait. Answer. I don't need to explain much. I will show the short notebook. I have already posted you the A-level chemistry short notebooks. A-level chemistry short notes. P block and S block short notes. Let me show you the short notebook. P block and S block. P block and S block. Right. Now can you see? Okay, without writing anything, I can directly show my short notebook for this. Lithium chemical reactions of here nitrogen. What are these? Lithium with nitrogen, lithium react, beryllium react, magnesium react. Aluminium won't react. Yeah, these are. Can you see the short notebook page number 2? Yeah, only these 3 react with nitrogen. So they have. I have given the color also here. Color also I have given here. P block didn't I give? Oh, I have posted this thing. P block I didn't give. I thought I had given. Okay, I will post
Yes,
this.
sir.
Given, right?
Yes.
Ishara, you didn't get. Ishara has not got the P block now. So you haven't given us the P block short note. Ishara, ask the others to share that or else I will send you. P block, no, sir. Okay, I'll send it now. After the class, I'll post it again. P block, can you see group 5 BiCl3, bismuth BiCl3, page number? I have given Roman numbers, the page number top. Group 5, look at here. Group 5, P block short. D block I had sent you. D block and organic chemistry. Each section I will be sending you the short notebook. Don't worry. At the end of organic chemistry also I will send you the short notebook. Organic chemistry D block I will send it. Right, I forgot that D block. S block and P block I have already. So can you see here bismuth chloride BiCl3 here BiCl3. Can you see here? Can you see that my short notebook page number 10? Short notebook page number 10. BiCl3 reacts with water forming BiOCl white precipitate. Here. Not only BiCl3, I have done everything else. NCl3 is yellow liquid and SbOCl also white precipitate. Here. These are the chlorides. Hydrolysis of the chlorides of group 5 elements. Okay, now I no need to waste time. You write near this question even in the oral paper, right? Short notebook. Everyone gave the second answer. I don't know why. You have not studied the short notebook. Maybe you have forgotten now. That's all right. But anyway, you have to, with the question, you have to refer the short notebook. So this is correct. This is correct. This is wrong. Aluminum can react. Okay. Right. Is that clear? The problem is S block I might have given somewhere the reaction with nitrogen, the magnesium I have an aluminium, because that is one example. If you heat magnesium and aluminium strongly in air, magnesium and aluminium diagonal relationship, they form both oxide and nitride. small percentage of ALN. Can you add here your short notebook? That one I had to give you. Can you please write here aluminium also? Diagonal relationship. Where? In your short notebook, page number 2, please write aluminium plus nitrogen ALN can be formed. ALN. 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 Okay. It's there. Like group 2 beryllium, magnesium, aluminium. Group 3 boron, aluminium. So this is diagonal relationship. And lithium and magnesium common. Lithium and magnesium here diagonal relationship. Group 1 lithium, group 2 magnesium, group 3 aluminium. These three guys pattern same. All three form lithium nitride, magnesium nitride, beryllium nitride and aluminium nitride, diagonal relationship. Lithium and magnesium, that's a common friends, and beryllium and aluminium. Okay, so that's why the answer is that one. But anyway, the second one I have given in the P block short note. Okay then, we discuss until question number 22. Okay, so in the I'll discuss next day, right? Because this is the latest paper, so therefore we have discussed this in bit in detail. 19 we discuss all the questions. No, in general and inorganic we discuss only physical and organic left, right? The remaining questions I'll discuss next day, right? Right. Okay, then we'll stop for today, and please try to complete this paper here. This one, what is that paper? This paper. Please complete this by next week. Not this one, sorry. Not this one. I posted new paper. Where's that? 19. It's not there. That organic chemistry one. Organic chemistry. Alkene reactions, past structure disease. That one I want to do at home. This one. Isomerism, sorry, isomerism. This paper. Please complete this, right? This is for homework. So next week I'll be definitely discussing this. They have done it or not. This is please complete this, because we have done isomerism. Alkane, aliphatic hydrocarbons also we have done. Isomerism also we have done. So next week I'll be discussing this, and remaining MCQs of 2020 A-level paper. Right. Okay, then shall we stop for today? Now you don't have problem with this time, so next week also we'll be doing Wednesday morning, right? Right. Okay. Anyway, if you want to go through this the explanation again, I'll upload this to YouTube, and please send me your email address. Then I'll forward send the link to your email. Then you can watch that anytime, because otherwise recording get deleted automatically after 3 days if I send the Zoom cloud recording, because due to the lack of storage. Right, then you can subscribe the YouTube channel, or you can just watch the previous videos if you want there. But only it's like others can't, only the class students can. Okay, then we'll stop for today, and we'll continue the rest next week. Have a good day, and God bless you, and stay safe.
Thank you, sir.
Thank you, sir.
Thank you, sir.
You're welcome.